this circuit design is a proof of concept. The ActivityBot will have these 4 hobby gear motors um, turn a spool by using an appropriate gear ratio. The spool will have paracord wrapped around it and will be fed through a hole in the robot. And it will have a hook attached to the end of the paracord. There will also be a pulley on the front of the robot, and the hook will first, the paracord will first be thread around a pulley at whatever anchor point is chosen, and then back and then around the pulley that is attached to the robot itself, and then back and attached finally at the anchor point. This is relevant information because what the force sensor in this circuit is doing is sensing the force that is applied from the pulley. It is attached to the pulley that's in front. So as the tension on the cord increases, so too does the amount of pressure that that pulley exerts on this force sensor. And in that way, the robot is able to monitor the amount of force that is being exerted on it at any given time. Unfortunately, within Tinkercad, there is not a way to simulate all of the power being provided to the Arduino from the power source, which would be necessary in the real world situation. However, I have um, provided as part of this the power coming from the 9-volt battery, going through the switch, powering here, and then eventually being used, if we trace this, to power the volt in, which would be sufficient to power the Arduino without the power source that the simulation offers us. So we'll just have to use our imaginations for that. If we start the simulation, first we must turn on the power. If without any pressure being sensed by the force sensor right now, the tension button rotates the gears at full speed in one direction, and the slack button rotates the gears at full speed in the opposite direction. After a certain threshold is reached in force, this LED turns on. We can see that it turns on right there. And at this point, now that a certain amount of force is being sensed, that is a warning that the amount of force that the machine can withstand is being reached. And so the speed at which the rotations occur is halved in either direction that we go. And then further, if it passes a certain threshold, the inputs of the buttons is no longer considered, and the gears continue to unwind to try and relieve tension without going at full speed in order to improve safety. Now, unfortunately, within this simulation, it is I'm not able to demonstrate pressing both buttons simultaneously. However, within the code, which I will go through now, these are my variables. I defined these functions here, and in the standard function, we can see that if the state of both of these is the same, whether it be they're both not pressed or both pressed, then the stop function will occur, which means that all of these are off. This is the setup. Here's the loop that I wrote. Yeah, that's how the whole thing works. You turn it on, press in either direction. At a certain point, it warns you. You go slower in either direction, and then it tries to stop you and go the other way on its own. Thank you.